going to look at trigonometry. I'm going to welcome you to the world of geometry because trigonometry is under geometry. So I'm going to welcome you to the world of geometry. Under this topic, trigonometry, there are things we are going to look at. What you need to do is to pay attention and you listen, because majority of things that you are going to use, which will help you better in this lesson, you're going to hear from me. All right, let's go. That is the topic. We're going to look at the definition of trigonometry. At the end of this lesson, I'm expecting you to know what trigonometry is all about by definition. Then secondly, we're going to look at the sine, cosine, and then the cotangent, tangent, cosec, secant of an angle. Not just only that, the third thing which we are going to consider under trigonometry is going to be special angles. Special angles. These are the three things we'll look at today under this introduction of trigonometry. I said number one, don't forget, I said definition. We're going to look at definition. And then number two, I said we are going to look at sine, cosine, and then tangent of an acute angle. And then thirdly, I said we are going to look at special angles. Special angles. Let's say 45, 30, and 60. These are special angles under trigonometry, which we're going to discuss. This knowledge is going to help us as we proceed. So what is trigonometry? If you are being asked, what is trigonometry? What will you say? Somebody will say trigonometry has to do with maybe drawing of a shape. Yes, not too bad. But hear me, trigonometry is the study of triangles in their relations to their sides and angles. The study of, I said triangle or triangles in their relations to their sides and then angles. So under this, we will be looking at the size of a triangle, we will be looking at the angles of a triangle by using the topic trigonometry. Don't forget, it asks you what is angle. Angle is the space between two lines that meet at a point. And if the line did not meet at a point, it means angles are not what? Yet been formed. Side, you're talking about the length of a triangle or the legs of a triangle. But in this topic, we are going to consider a specific type of triangle, which is what? Right-angled triangle. I say what? Right-angled triangle. I have defined trigonometry. To recap, I said trigonometry is the study of triangles in the relations to their sides and angles. So these two ways are key to us as we proceed. Angles and sides. You'll be seeing that as we are solving and be dissolving, what you'll be seeing, sides, angles, sides, angles, because that is all what about trigonometry. Now let's go to sine, cosine, and tangent of an acute angle. Somebody may say, why not obtuse, reflex, and other type of angles we have? If you know how to find the sine of an acute angle, the idea here will also help you to find the sine of every other angle you can imagine. So sine, cosine, and tangent of an acute angle. The question is, what is an acute angle? An acute angle is an angle that is less than what? 90 degrees. So any angle that is less than 90 degrees, it is what? An acute angle. For example, 4 is less than 90 degrees, it is an acute angle. 55 is less than 90 degrees, it is an acute angle. And the rest of that, but not 90 degrees. 90 degrees is not an acute angle. So now, let's go to the subtopic, sine, cosine, and tangent of an acute angle. We are going to look at the sine and cosine. We also consider the tangent of an acute angle after defining what trigonometry is. Sine, I told you, it's just a word which we use to describe an acute angle. Cosine, another word which we use to describe an acute angle. Tangent, also used to describe an acute angle. May not be necessarily only acute angle, can be other angles. So when you hear of sine, cosine, and tangent, remember they are referring to angles and what? And sides of a right angle triangle. All right. For a sine of an acute angle, we are going to consider a right angle triangle. And for a right angle triangle, you have one of the angles as what? Angle 90 degrees. Now, if this is right angle triangle, there's a need for us to identify the hypotenuse side and the adjacent sides. This is the symbol of 90 degrees. This symbol of 90 degrees means that here is the hypotenuse, because the hypotenuse is that side that is opposite angle 90 degrees. You can see my hand. This is angle 90 degrees. This is the hypotenuse. Opposite angle 90 degrees hypotenuse. So any other side can be called adjacent. Can be called what? Adjacent. But if I consider this space between these two lines that meet at this point, and I put angle theta, I'm going to alter this so that it will give me what I'm looking for. So that means if this is theta, angle theta, consider this angle, here we turn to opposite, because that is the side that is opposite what? Angle theta. And then the remaining side become what? Adjacent. Even if it is turned, you don't need to get confused. Here is the angle 90 degree. So if this angle 90 degree, here becomes your hypotenuse. And then if here is your hypotenuse, if I'm to consider this angle, it means here is opposite side to this angle. And then here become what? My adjacent. That is how you identify it. So having said that, let's look at sine theta. This is the abbreviation of this. Instead of writing this repeatedly, we just take the short form of it. Now, sine theta means I want to consider this angle. So if I'm considering this angle, this is, I now told you are going to write, don't forget this thing, so, ka, toa. You see this thing? It's a key in this lesson. So, ka, toa, not English words, an acronym, which we use to summarize what we are doing today. So now, sine theta is equals to, look at sine. X stands for sine, O stands for opposite, anywhere you see O, C stands for cosine, and then anywhere you see A, it also stands for adjacent, and then letter H stands for hypotenuse, anywhere it is hypotenuse. That's what we have there. Sine, letter X, opposite, that is sine, letter O, opposite, hypotenuse. Cosine, adjacent, hypotenuse. Tangent, yeah, this one was mixing, that is tangent, letter T, that's what we are going to use. So sine theta, consider this angle, means opposite over hypotenuse. Opposite over hypotenuse, which is this length divided by this length. So now let us use letter to represent this length. We have here the size of this shape. Now, if this is the right angle triangle, and I'm to consider this angle opposite, look at it here, x, all by what? Letter Z, which is here. So this represents any number, any figure on the shape. So with this now, I can substitute the respective values, and then I will now find what? Sine theta. We're going to look at example. Now, let's take cos theta together. Let's look at cos theta together without wasting time, because it's still almost the same thing. Cos theta of an acute angle. Look at adjacent over hypotenuse. Adjacent over hypotenuse. So this is adjacent over hypotenuse, which is now equal to adjacent. Where is the adjacent? Letter Y. Hypotenuse, letter Z. So these are the question we are going to look at. Then let's also consider the tangent. The tangent, you now have tan theta, short form for tangent, tan theta. Tan theta is, look at it, opposite over hypotenuse. Opposite over hypotenuse. And this is equals to what? Opposite. Where is the opposite? Letter X. Where is the hypotenuse? Letter Z. These are the three equations we are going to use to simplify or evaluate sine theta, cos theta, and tan theta for an acute angle. Now let's take one simple question. This was given to us. Let's say here is the theta, and then they put here 5. Then we have here as 3, and then we have here as 4. The question now is find A, or let's say 1 cos theta, 2 sine theta, 3 tan theta. Solution. Solution. Let's go. If I were you, the first thing I will do, I'll write this somewhere. This is what I need to always remember under trigonometry. Now, let's go now. Number 1, cos theta. Cos theta means adjacent over hypotenuse. Adjacent over hypotenuse. So I'm going to write adjacent over what? Hypotenuse. How do you locate it? Please, you draw the shape, or on the shape, you can just use your pencil. Here, this is 90 degrees. I told you the side opposite 90 degrees is hypotenuse. That means here is what? Hypotenuse. If I'm to consider this angle, angle theta, it also means here is what? My opposite. And then here become my what? My adjacent. So now, cos theta means adjacent divided by what? Hypotenuse. So now let's do it. Adjacent, trace it, 4. Hypotenuse, 5. Final answer. Have simplified. Then go to 2. Sine theta. Sine theta is, look at it here, look at the grandmasters, they are here. Sine theta is opposite over hypotenuse. Opposite over hypotenuse, which is now equals to what? You go to your shape. Opposite to this angle is 3. So I put my 3. Adjacent to this angle, hypotenuse to this angle is still 5. So, simple. Then go to 3. Let's say tan theta is equal to what? Tan theta equals to what? Go to the grandmaster. Look at it. So, T stands for tan. Opposite over hypotenuse. Sorry, opposite over adjacent. So I put my opposite over adjacent. So which is opposite, go to your shape. Look at 3 here, is on that length. And then adjacent is what? Is 4. Simple. That's how you apply sine, cosine, and tangent of an acute angle. So you must not forget SOHCAHTOA. That is what you are going to use. Don't forget it. Now, having done that, let's go to the step 3 of the lesson, which has to do with special angles. Let's look at special angles. Special angles. These angles are 30 degree, angle 30 degree, angle 45 degree, and then, angle 60 degree. These are special angles. Under the special angles, we are going to derive sine theta. We're going to derive sine 30, cos 30, and tan 30. Sine 45, cos 45, tan 45. Sine 60, cos 60, and then tan what? Tan 60. So doing that, let's consider an equilateral triangle whereby each of the sides is 2 units. So if I divide here into 2, that means, don't forget, here is 30, here will be what? 30, here is also 60. So if I divide here into 2 with a bisector, it means here will be 1, here will be what? Here will be 1. Now, if I use it now to find, but this is a right angle triangle, you cannot use the Pythagorean theory. Here is 2, here is 1. So here will give you what? Root 3. Pythagorean theory will give you root 3. So now, automatically, this is what you are going to have. So you don't need to draw fully, just take half and keep it somewhere as a guide. These are 30 and 60 degrees. I told you this side is root 3. Here is 2. Here is 1. So when I am to consider sine 30 degrees, first of all, go to your grandmaster. Your grandmaster is SOHCAHTOA, and that means opposite over hypotenuse. I will write opposite over hypotenuse. Now, go back to your shape. I am looking at this angle. So if this is angle 30, here becomes my opposite. Here remain my hypotenuse, and then here becomes my adjacent. So with this identification, you can now proceed to find sine 30. Sine 30 is now opposite over hypotenuse from SOHCAHTOA. So you now have opposite is 1. Hypotenuse is 2. Simple as that. Then cos 30 degree is adjacent over hypotenuse. Go to your shape. Consider the same angle. Opposite to 30 is 1. And then hypotenuse, adjacent, sorry. This is adjacent over hypotenuse. Adjacent, which is root 3. Look at adjacent. Root 3. Adjacent over hypotenuse, 2. Then we talk about tan 30 degree. TOA, opposite over adjacent. And that will give you opposite is what? 1 over adjacent. Look at root 3. You can't keep it like this. If you rationalize this just multiply it by root 3 over root 3, which is going to give you root 3 over what? Over 3. Root 3 times root 3. Root 3 times root 3 is not root 9. Or root 3 times root 3 is not 3 root 3. These two roots will cancel each other. Under sword, these two roots will cancel each other, and you have root 3. So tan 30 degree is what? Root 3 over 3. Under sword, I will prove to you how this becomes 3. Then we have sine of 60 degrees. Still the same shape. Still the same shape. So now, if I'm to consider this angle, I have to identify this shape again. But my hypotenuse still remains the same because this does not change. So this is now opposite. Here is now what? My adjacent. So for sine 60, which is opposite over hypotenuse, your opposite side now is now root 3. And then your hypotenuse still remains 2. You discover something. I just noticed that cos 30 is equal to sine 30. Look at their two values. Look at it. They are the same. So anywhere I see cos 30, I can replace with sine 30. I'm right, because they have the same numerical value. Now, let's go again. Cos 60 degree. Cos 60 is adjacent over hypotenuse. Yes, adjacent over hypotenuse. You go to your shape. Where is your adjacent? 1. Where is your hypotenuse? 2. I discover another thing again. That sine 30 is the same thing as what? Cos 60 degrees. Look at their values. 1 over 2. 1 over 2. So simple. So simple. I love this. I love this. Tan 60 degree. Let's go to tan 60 degree. Tan is opposite over adjacent. Opposite over adjacent. Where is your opposite? Root 3. Where is your adjacent? 1. So this is the same thing as what? Root 3. So we are through with 30 and 60. So let's go to 45 degree. Under 45 degree, we consider a square of unit side 1, 1. Hypotenuse side will be what? Will be root 2, and this is 45 degree. So if you have to consider this, the next thing you identify the side. If this is angle 90 degree, the side that is opposite angle 90 degree is your hypotenuse. And then if you have to consider this angle 45 degree, it means here is your opposite, and then here is your what? Adjacent. You have done that, have you? Okay, let's go. We're going to look at sine 45 degree. What is the value? Sine 45 degree. This is now equal to, sine is opposite over hypotenuse, which is now equal to what? You go to your shape. Opposite is 1. Where's your hypotenuse? Is root 2. Simple. Then you go to cos 45 degree, which is what? Adjacent over hypotenuse. Adjacent over hypotenuse. What does it mean? Look at adjacent is 1 for 45 degree, and then hypotenuse is what? Root 2. So you cannot keep it like that. Just multiply this by root 2. So you now have root 2 all over 2. These 2 will cancel out. The same thing to here. 1 over what? Root 2 over 2. That's what you are going to have. Hypotenuse is root 2. Adjacent and opposite. Adjacent over hypotenuse. Yes, correct. So we are correct. Then tan 45 degree is equal to opposite over adjacent, which is now equal to what? Opposite over adjacent is equal to what? Look at here. Adjacent, opposite. So opposite is 1. Adjacent is 1. So tan 45 anywhere in mathematics is equal to what? 1. Cos 45 anywhere in mathematics is equal to root 2 all over what? 2. So with this now, they can just ask you, let's look at the application. So let's look at the application of what we just derived. Let's look at the application. Let's look at the application. Just one question. Let's say they say evaluate tan 45 degree plus cos 60 degree. That's what they give to us. I don't need to get worried. If I have this, I have this. What you need to do, master this drawing. Master this drawing. Then you are good to go. Anytime you see these special angles. So what I need to do, just to draw this somewhere, 45 degree, and then this is my unit length, and then this is square root of 2. With this, I am good to go. The next thing I'm going to do is to identify, I have 45 and I have 60. So this is 60, opposite over adjacent. Okay, now, so I'm good to go now. Solution. Then, first of all, what is your tan 45 degree? If you know it, before now, tan 45 is 1. That's what we just proved here. But in case you can't remember, you can just always rely on this. Tan 45 is opposite over adjacent, which is 1 divided by 1. 1 divided by 1, which is equal to what? 1. Then you come to cos 60 degree. Cos 60 degree, considering this angle, opposite over what? No, not opposite. You are using adjacent over hypotenuse. Look at the grandmaster. Adjacent over hypotenuse. adjacent over what? Hypotenuse. And that is going to be, adjacent is 1, your hypotenuse is what? Is 2. So now you now go back to your question, tan 45 degree plus cos 60 degree, this is now equals to tan 45, substitute 1. And then cos 60 degrees is what? 1 over 2. So under this, take your SCM, but the best way to go, if I were you, use 2, multiply this 2 plus your numerator here divided by 2. This will now give you 3 over 2. You are solved. That is how we apply spatial angles. Spatial angles, angle 30, angle 45, and angle 60 degree. So at this point in time, I'm going to call it a day. When next we come, we'll now look at other aspects of trigonometry, which has to do with looking for, evaluating the angles under trigonometry, and then we'll also look at the graphs under this, and then under that graph, there's something I'm going to introduce to you, an acronym. It's not everywhere. When we come next time, we'll introduce that acronym to you, Sekoto and Sekotfinitive, and then I will tell you how to derive it, and it will help you anytime, any day you are solving mathematics under trigonometry. As you do that, exams without calculator, exam without 4-figure table, this is where it will take you to. So if you don't know it, it's very difficult for you. But I assure you, if you are following me under this platform, I bet you will become another oracle, just as I am. Thank you so much, and see you next time.